Hello, everyone. Today, I'm excited to explain how transitioning from diesel buses to electric buses in major cities can bring massive benefits. This study shows how this switch helps both the environment and city budgets. Let's dive into the details, especially how the models work to demonstrate these impacts. Here's a quick overview of what we'll cover in this presentation. We'll start with an introduction and background of the research, followed by the models that demonstrate how electric buses reduce CO2 emissions and noise pollution. Then, we'll explore the financial implications of transitioning to electric buses, and finally, wrap up with the key conclusions. First, let's begin with the background of the research. Diesel buses contribute significantly to urban pollution, increasing both air and noise pollution levels. They also pose serious health risks, causing conditions like lung cancer. Plus, diesel is a non-renewable resource, making it unsustainable in the long term. By switching to electric buses, we can reduce CO2 emissions, lower noise pollution, and cut financial costs in the long run. The question is clear. Why not make the change to a cleaner, quieter, and more sustainable transportation solution? The first model we are going to look at is the carbon dioxide emission reduction model and its implementation. The model shows how much pollution can be reduced by switching to electric buses. The first equation consists of two main parts. The portion highlighted in yellow represents the total CO2 emissions from diesel buses in the city per day, and the part highlighted in green represents that of hybrid buses. The meaning of each variable is given in the table below. The first equation calculates the total emissions of greenhouse gases per day, while the second calculates F, the total emissions after the transition to electric buses. The equation adds up the total emissions from diesel and hybrid buses after replacement and also includes the total emissions from electric buses. Subtracting F from C gives the total reduction in greenhouse gas emissions per day. When electric buses replace diesel ones, emissions drop dramatically because electric buses cut CO2 emissions by 60%, emitting only 40% of what diesel buses would. For example, in the city of Sheffield, England, the model shows that after the full transition, CO2 emissions would drop by about 375 tons per year, equivalent to taking hundreds of cars off the road. Sheffield has 119 diesel buses and 21 hybrid buses, with each bus operating for 8 hours a day. Inputting these numbers into the model gives us total emissions of 1,716.15 kilograms per day currently and 782.75 kilograms per day after the transition. Subtracting F from C gives 933.4 kilograms of total reduction per day, and multiplying by 365 days results in a total reduction of 375.44 tons per year. The next model we developed calculates the reduction in noise pollution after the transition to electric buses and its implementation. Traditional diesel buses create a lot of noise, especially in busy urban areas. Here's a graph showing sound pressure levels determined by bus speed. Through regression analysis, a quadratic model fits best for modeling the decibel levels of buses. V represents the bus's velocity, so values will vary by city. The total noise reduction in the city can be modeled by the equation below. This model subtracts the sound pressure of electric buses from the average sound pressure of diesel and hybrid buses to calculate the noise reduction in decibels. In Sheffield, where buses travel at 20 miles per hour, diesel buses generate nearly 78 decibels of noise, similar to a vacuum cleaner. Electric buses, on the other hand, generate only 68 decibels. The model estimates that after the switch, noise levels would drop by over 7 decibels, a noticeable difference in residential areas. The next model we will examine is the financial model and its implementation. Although the initial investment for electric buses is high, cities save significantly on operational and maintenance costs. First, The total upfront cost for replacing buses and chargers can be modeled by the equation below, since the cost of an electric bus and a charger typically amounts to about $750,000. Electric buses are more cost-effective in the long run due to lower fuel and maintenance costs. This can be modeled by the equation below. The portion highlighted in yellow represents the average cost of an electric bus per mile. The part highlighted in green represents the mileage per bus per day, which varies depending on the city, and the part highlighted in blue multiplies everything by the number of buses being replaced and 365 days. By applying the models to the city of Sheffield again, we get an upfront cost of $52,500,000, a yearly electricity cost of $3,571,276.80, and a yearly maintenance cost of $120,000 cost of $4,496,800. Here's a comparison of the costs for diesel buses. Operational costs of $7,732,402.94 and maintenance costs of $12,509,280. A diesel fleet costs around $20 million per year to operate, while an electric bus fleet would cost only $8 million. This $12 million difference demonstrates that electric buses are a smart long-term investment. It's time to wrap up all the advantages of transitioning to electric buses. In conclusion, although there are higher initial costs and challenges with new infrastructure, transitioning to electric buses offers long-term ecological and financial benefits, such as reducing carbon dioxide emissions, lowering noise pollution, and cutting long-term financial costs. To achieve a more eco-friendly city, both citizens and the government must support the shift, as it can lead to significant annual savings. And that is the end of the research presentation. Thank you and have a good day.